Yesterday in Sherman, Texas, Jensen Huang signed a white steel beam, shook hands with Coherent CEO, and stood beside a factory expansion most people would never connect to AI. The building going up there is about lasers, tiny indium phosphide lasers that carry data between AI chips at the speed of light. The company building this factory is Coherent. They make photonic components that let servers talk to each other using light instead of electrical signals. NVIDIA just invested $2 billion in them, signed a multi-billion-dollar purchase commitment, and showed up in person for the groundbreaking. That is a lot of money for something most people have never heard of. Here is the problem they are solving. Inside a modern AI data center, thousands of GPUs run calculations in parallel. But those GPUs need to constantly share data with each other. Weights, activations, gradients, intermediate results. All of that data has to physically move from one chip to another, one rack to another, sometimes one building to another. Today, most of those short connections run through copper traces and cables. Copper works fine at short distances and low data rates, but AI clusters are getting bigger and faster, and copper has a physics problem. Push the data rate high enough, and the link burns more power while the useful distance shrinks. Past a certain point, the electrical signal falls apart. Light gives engineers more room. An optical signal can carry more data over longer distances with less power loss. The longest links between data centers already use optics. The shift now is that the optical boundary is moving inward, into racks, between switches, and eventually right next to the chips. That is where Coherent comes in. They make the indium phosphide wafers that become laser diodes inside optical transceivers. Indium phosphide is a compound semiconductor, not silicon. It is one of the few materials that can efficiently turn electricity into coherent light at the wavelengths data centers use. At OFC 2026, Coherent showed a 6.4 terabit co-packaged optics module powered by 400 milliwatt indium phosphide lasers running at 3.6 picojoules per bit. Those are small numbers with big consequences. A picojoule is a trillionth of a joule. When hundreds of thousands of optical links are running in one AI cluster, the difference between 4 picojoules per bit and 10 picojoules per bit becomes real power, power that can go back to running GPUs. This is what co-packaged optics looks like in practice. Instead of plugging separate optical modules into the front of a switch, the photonic engine sits directly next to the switch silicon, inside the package. The electrical signal travels a much shorter distance before it becomes light. That means less wasted power and more bandwidth packed into the same box. NVIDIA already has co-packaged optic switches shipping. QuantumX Photonics is an InfiniBand switch with 1.6 terabits per port and more than 100 terabits total. Lambda, one of the first customers, got their hands on one last month. But here is the supply chain question. NVIDIA can design the switch, design the network, sell the system. The lasers inside, the indium phosphide components that actually generate the light, come from companies like Coherent. Demand is already running ahead of supply. Coherent CEO has said they are doubling indium phosphide capacity and still racing to keep up. That is what the Sherman, Texas expansion is about. Coherent is doubling manufacturing production space and quadrupling wafer production capacity at this site. The local project is valued at roughly $650 million. It is expected to create more than 1,000 jobs, including more than 550 direct manufacturing and engineering roles. The facility will produce 6-inch indium phosphide wafers, the largest standard diameter in the industry for this material. NVIDIA's $2 billion investment in Coherent, announced in March, is separate from the building cost. That deal included a multi-billion-dollar purchase commitment and capacity rights, meaning NVIDIA has locked in access to Coherent's optical output for years. On top of that, Coherent just announced a CHIPS and Science Act letter of intent for up to $50 million in direct federal funding, plus about $20 million in prior state and local support. Step back, and the pattern is clear. NVIDIA sells the GPUs. NVIDIA designs the networking switches. Now, NVIDIA is funding the company that makes the lasers that go inside those switches. The integration reaches all the way down to the raw material, indium phosphide wafers grown in Texas. The trade-off underneath all of this is straightforward. You can keep buying faster GPUs, but if the links between them cannot move data fast enough, those GPUs wait. The network becomes the constraint. Light helps with the physics. Sherman is where NVIDIA wants more of that light to get made.